These are not very simple to do it, so we need sponsors. Google is one of our main sponsors who always provide the venue facility for us once in a month. Apart from that, we have Type. Type is one of the sponsors for today who has given us some flags to give away. And we would be having one of the speakers from Type who will be talking about GitOps. Yeah, so since we are K8SUG, we also Yongkang is CNCF ambassador. He's the only one ambassador from Singapore till now. And we are also sponsored by CNCF. As I said, main sponsor is Google, CloudCasa. CloudCasa is our long-term sponsor, so they help us to start up the meetups in different regions as well. Are you guys aware? We are present in Australia and Canada. So yeah, we are present in 3 countries now: Singapore, Australia, and Canada. So these sponsors like Google, CloudCasa, JFrog, what they do, they help us to set up those meetups in new countries, and they help us at many times. These all things needs money, right? So that's how they we get money from them. Our mission statement, as you guys see, and what's today? So today we have 3 sessions. The first session will be from MunKiat from Type is the lead solution architect who will be talking on GitOps and Kubernetes. Second topic would be Weiyuan Liu. He is GDG Cloud Singapore expert, and he would be talking about migrating to cloud and the use case, what he has learned during his tenure. And third, we have our friend Yogi. He is principal solution engineer at Yugabyte, who will be delivering third topic. This is a LinkedIn page if you guys haven't liked or followed it, so you can scan the QR code, join us. Okay, if any of you who wants to join us as a sponsor, you're also welcome. So you can do this form. Or you know someone who would be willing to sponsor. It's not necessarily you guys. One who would like to do it. We really appreciate you doing that, letting people know. Anybody who wants to join as a speaker, we welcome the community, the speaker. You can again scan this QR code, fill in the form, and fill in your topic and what you're interested, and we'll reach out to you for community events. And also we look for volunteers. QR code for volunteers. Okay, so if anyone of you who would like to volunteer with us, please reach out to me. We will add you to the volunteer group because we need volunteers to do this. We really appreciate if everybody is willing to do that. And without further ado, I would like to call Lawrence. You would like to? So I would like to call Lawrence. He is one of our main sponsors from Google, and he would like to talk 5 minutes about the Google Startup for Cloud.
Hi everyone. I will need 5 minutes. I think we're very good point. Yeah, my name is Lawrence. Okay, before that, who's the first time? Oh, nice. Okay, this is a very interesting. Okay, so yeah, y'all should actually come earlier because they actually invited a lot of good speakers previously. Yeah, but they will continue to actually bring a lot of good speakers, so don't worry about that. Okay, so yeah, so Google Developer Space, right, is actually a space where we actually created to actually host our GDG groups as well as our broader communities. So we actually host a lot of monthly meetup, like from data science to machine learning to AI, and then like with Kubernetes as well. So we're starting to reach out to startup as well. So if there's any good startup meetup group that you think that is suitable for us to host them, please let us know. Okay, yeah. So Okay, this is our webpage. Okay, this is something. Yeah, so we want to actually get you all to sign up into this Telegram group chat. Yeah, so what we do here is that don't worry, we are not going to actually sell you anything. Okay, what we do here is that we actually list out all the events that we are hosting, and it's open to all. So just go in the page, see the information, and then whenever you're interested, just sign up. Okay, yeah. So I'll give you 30 seconds to sign up. Okay, yeah. So we actually host it machine learning, AI, if you're interested. Okay, but don't worry, because I think we also paste, some of the QR code on the wall, so you can scan it. Okay, cool. The next one. Okay, we'll take some photographs, and then that's actually for our marketing purpose. So we'll make nice banners for our communities, and then so that we can attract more people to join the community as well. Don't worry, I'll take very nice photos. Yeah, and then this is actually for those who are planning to do a startup. Okay, so if you're planning to do a startup or you already have done a startup, this is actually a good program for you to actually know what this Google Cloud team is offering. So this program, right, is actually for new startups. Let's say you actually incorporated less than 5 years and you actually has I think less than $5 million funding. You can actually apply for this one. So, but of course, I think the details, our customer success manager will approach you guys after you apply. Yeah. So, and if you're doing a Web3 or AI related startup, okay, we actually give out more Google Cloud credits. Okay. Yeah. So if you're interested, you can scan a QR code and then sign up from here. Yeah. Cool. Yeah. Okay. So, yeah, thank you so much. So that's all from me. And then, so how some house room. So washroom is at the back, and over here we also have free Wi-Fi. So you just look for Google Guest and then just log in. No, I think password required. Okay. So, and in a case of emergency, just follow me to head down and sit over there and put a call. Okay, cool. Yeah, thank you so much for joining us today. I think today is Friday. So this shows, a lot of love for this community. Yeah, applause for all of you. Okay, thanks.
Thank you very much, Lawrence. And with that, I would like to call on stage MK to come and present his first topic. MK, over to you. Might you use any both of them? Closer to the mic. Wait. Let's connect this.
Screen share. I think I just which window? It's not right because that's on.
Share the desktop too.
Yes,
And then you can just drag it. Yeah.
okay.
It's
I
just
do
practice.
demo.
Yeah, practice.
Sorry. I doing because there's no time. It's fine.
No, that's fine. Yeah, you can.
Well, that's okay. This works. Okay. Hey everyone. Thanks for coming. I know it's a Friday. Most people I'm looking at demographic. Most of you would be happier. Would be better off actually having beers with your friends or something. But I think it's really good that you guys are come to the event today. In today's talk, my topic is getting closer to GitOps with K8 operators. Honestly, the title doesn't make sense to me. I kind of made that title in a rush. Could have been a better title today, but today I'll be focusing a lot more about Kubernetes operators. The reason for that is largely because when I was approached by Ritesh to give a talk around that, I looked through what the K8SUG group was talking about mostly. there were a lot of cloud-based, a lot of migrations, a lot of backup, a lot of high availability topics. But really, I think there aren't too much about operators itself. It's one of the, I would say, one of the more mainstream things. It started in 2016. 6 years old, roughly was the age of Type. And I figured it would be a really good way for everybody to just learn about operators and what they're used for. Okay, so this is my introduction. I skipped that. This is a picture. So I'm an architect with Type. So I came back from Greece last week. So this is the annual retreat with Type. Type is an IMDA accredited API management platform. We are based in Singapore, London, and Canada. So the one in the green circle is me. And I've been with Type for about 1.5 years. Prior to that, I was working with a managed services provider for about 7 years before deciding to take the leap and join a startup, try something new. On the right, you can see is what I do outside of my work hours. That's Hibiki. So outside of work, that's where I spend my time. It's really, really difficult to reject that face whenever she's smiling at you like that. So work, dog, that's pretty much story of my life. So today I will spend about 20 minutes. I've been given 25 minutes. I know there is always a tendency for speakers to extend. Then the organizers would start staring daggers at me. The next speakers would think that I'm eating into their time. So I'll keep it short and sweet, 20 minutes today. We'll go through a couple of things. First would be a refresher in terms of things that you probably might know. I do know that there's a wide range of, there's a wide demographic here today, ranging from people who are just getting started, people who are a little bit more intermediate, and people who are just totally exploring, new to the topic, right? So we'll just do a quick refresher so that everybody in the room is baseline together. I'll talk about extending the foundational concepts. So Kubernetes APIs extending with CRDs and the operator pattern itself. We'll talk about the operator maturity model. So that's one of the things that I've also realized that not all operators are built the same. Number 4 would be, should you build your own or should you just use something over there? I'll give use cases from Type. We build our own operator around that. The pain points, the decision points behind that, why we did it, and then you guys probably could see if it relates to you. Number 5, really risky item, always very risky to do demos. So bless me, if I don't overrun, we have time for a demo, I'll show you guys a little bit of a custom CRD or an operator from Type. One thing I've learned in about 5 years, about 7 years of working from my mentor is always start with the end. So you always start with your summary. Don't drag the summary all the way to the end. So here's the summary first, right? By the end of this session, you should be able to understand what the nature of operators are, where you can find them, generally on GitHub, Operator Hub. Should you build your own operator? So the decision matrix behind that, some of the key considerations around that, especially revolving around the maturity model, right? So you think you step into the shoes of why and how to do it, and then to marry together with the GitOps flow, how does it look like with operators? So I'm quite sure there are some of you with the same face. You probably already know this, so I will try to be very, very brief about this. Kubernetes and the declarative model, right? So it's really, really simple. Basically, it's just a description of the desired state, the what. You don't have to say the how. It's really useful because it saves a lot of time, right? You just say what you want. Kubernetes does the rest for you. In an example over here, I gave 2 examples, right? If I work in a bakery as chef, making bread, it just says divide dough into equal portions. Me as the baker would know to. So they want the what, and then I just know how to do the subtraction, addition of dough into equal portions. Likewise, you guys who use Grab, you guys just say where you want to go, and then the driver decides how fast to go, which route to take, or which routes to avoid, maybe ERP. So these are the basics around that. The next one is controllers in Kubernetes. There's also one thing which I think I've also heard from Ritesh is that most of the people today are a little bit more of a, on the earlier side of learning Kubernetes. And one of the things which I also do learn is that anyone can make things complex. So the trick is to make things simple over here today, right? So I'll try to be as simple as possible. I won't be overly technical, but if there are any questions, let's park it for the end. So back to controllers itself. So controllers basically just run the control loop. It's adapted from the industry, right, where it just runs a loop, which there is an observer. It observes the actual state, finds the differences, and then moves the state closer to the desired state itself. So in the desired state, that's where your declarative model happens. And the action of moving from actual to a desired state is what we call reconciliation. This is quite an important concept. It's going to occur quite often. We'll hear that quite a fair bit today. And for those who are quite familiar with Kubernetes, you've touched about it. Replica sets, deployments, stateful set, job statement sets. These are all controllers. Okay, so at the back end, they are controllers. For those who are not familiar, I'm showing my age over here. The picture on the right is from Groundhog Day. It's a really nice movie. If you haven't watched about it, it's about a guy who lives a certain point in time over a certain day, actually, over and over again, and then he finds a way to escape the time loop. So it's very reminiscent of control loop. If you haven't watched it, watch it. But if you watch it, don't look at the year because that will reveal my age. So also another set of basics. I've included a picture of how the control loop would work. 3 scenarios between desired, actual, and the action to take. So if there are 3 replicas, the desired state is 3 replicas, and we have 2 replicas, action would be scale up. If we do have a desired state of version 2 and the actual is at version 1, Kubernetes updates it. However, if there are some replicas and desired state is none of it, you just do a cleanup over here. So I think long gone are the days where I'm not too sure if any of you are from like a quite legacy system background. You guys are very, very cautious about create, update, changes, all of that kind of stuff. Kubernetes actually does form a little bit of a safety net for you in terms of mistakes, if you were to put it that way. I'll deviate a bit and touch about on GitOps. And before we jump back into operators, controllers, and all of the very nice stuff. So the principles of GitOps are actually extracted from Open GitOps. I've taken them from Open GitOps. Nothing really creative around here. Copycat work for myself. It's really just 4 points. Expressing the desired state declaratively. Everything stored in Git, which is version and immutable. There are software agents, right? Essentially the controls which pull the states. And then constant reconciliation is happening. So GitOps is basically these four sets of principles. And what you see over on the right itself is basically everything centering around Git. That's where the primary focus is. So things like Terraform, Ansible, Prometheus, Kubernetes, Jenkins, you'll hear them over and over again, and it's very, very common stack. Now, so there probably are some brilliant people in CoreOS in 2016 who thought, could we take all of this goodness, all of this magic, right, and apply that to applications? Because what we have right now, it's really the stateless stuff, right? What can we do with stateful stuff? Can we actually create, a machine that embeds runbooks, operational knowledge together? So they are really, really smart guys. I'm definitely not one of them. But then they've managed to make it happen, right? They're from CoreOS. And the way they've done it is actually through extending Kubernetes. So there are 2 components to this, okay? One is custom resource, a custom resource definition. And then the next one is operator. I'll cover custom resources first. So custom resources started as a way of prototyping new Kubernetes capabilities. So when Kubernetes was released and they want to iterate that, it's actually through a very, I would say, older form of custom resources. However, they found it really convenient, and then that became a quick way of extending the Kubernetes API. So from a way of prototyping, it made its way into mainstream Kubernetes branch. It's also a first-class citizen, which means that you get to interact with the API just as you would with the built-in Kubernetes resources. So you can use kubectl, apply, and it will have the same effect around that. You don't have to do any additional work around that. So essentially, if you look at the sheep over there, same. There's no difference around that. You store the CRDs in Git, and that's not, but that alone itself is quite plain. It's not magical itself. It's basically a store of data of state that you want, right? The magic happens when you combine them with controllers, and these are the custom controllers that I'm going to talk about. So not the basic ones, and these embed the domain-specific operations and capabilities that allow us to have the operators that we have today. Operators, robots, essentially. So I've included a link where operators were announced, the concept of operators announced by CoreOS. It's a really, really good read. I think the slides will be shared. So if you do have the time, do read it. It's a really good insight as to the design thinking around what they were facing and how they came to that conclusion. So started by CoreOS in November 2016. So that's about 7 years. For 7 years. Custom controllers are actually just they're just controllers in K8 version over the CRs. The concept of that is that these controllers would be like a human operator. So they are like people with knowledge of runbooks. They know what to do in every scenario over there. So it's not just very infrastructure-like that we're exposed to, pods, deployments. These are very infrastructure-like concepts and objects, right? So operators allow us to embed domain-specific knowledge around operating a workload. However, there's just like humans, there's also a skill and maturity level to operators. So there is a really cool maturity chart that I'm going to show you next. You can understand people who just started working and all the way who are with 20 years of experience. So there is a model after that. Okay, so simple diagram as well. Here is the custom operator that is managing resources that are outside of Kubernetes. It can be anything. It can be managing S3 bucket over here. That's the picture, right? It can be managing type API definitions. It can be managing your backups. So it can manage essentially anything that you want. And it's a very interesting concept because it forms a really good benefit of having a single pane of entrance, which is your Kubernetes or Git, essentially. And operationally, it's going to be much more neat. It's going to be easier to troubleshoot and diagnose. This is an example from CoreOS. I've just taken a very simple example. I like the elegance of the example over here. What it embeds, aside from doing the magic that you want to do, it's a black box that you don't know what to do. But it encapsulates the example of when you want to expand on etcd, right? You want to upgrade it, you want to scale it, right? You just do declarative state the version and the size that you want, right? So saying what you want, and the operator does the rest of the things. So it's not talking about pods, it's not talking about infrastructure, it's not talking about networking. It's about the workload itself. So the operator creates a DNS name, right? So there's some domain knowledge. It adds instances, some level of infrastructure operations. And then it also informs the etcd cluster members of its registration over here. There's also an example, which I just didn't put inside, but in a case where if you want to have a backup, it can be done as well. So it really functions like someone who is skilled. Maybe, I would say, with this example of an operator, it's probably a level 3 operator. We'll talk about the maturity cycle, maturity chart soon. But then this is like a level 3 operator. It has some knowledge in terms of full lifecycle, upgrading components, and management of them. This is the maturity model. Likewise, I've copied it from operatorframework.io. It's a very useful tool in terms of understanding operators and their capabilities. When you evaluate operators, what to use, it also helps manage your expectations in terms of what it can do, what it can't do, and you know what you want to work around with. So level 1 and level 2 are very, very common. In Operator Hub itself, level 1 and level 2 operators are coming to be around 160. Last I checked was about 160-ish operators around that. These are really basic installs. So people who so basically like a junior level engineer who comes in, installs the application, does the configuration with runbook around that. They can also do patching, upgrade, minor version upgrades with that intelligence around that. One thing around that, which I also do say, and some of you probably might be thinking, is that what's the difference between that and Helm charts? Level 1 and 2, and if you have an operator that's doing level 1 and 2 tasks, you might be better off using Helm charts. Level 3 is where it starts to get interesting. It touches into application lifecycle, storage lifecycle, monitoring, as well as auto scaling, right? So level 5 is a really impressive feat of engineering. There are probably, I would say, when I last checked, it was probably about 30 operators in Operator Hub that actually have reached level 5 from its definition. Level 4 would be slightly lesser, and level 3 is a bit more than that. But level 5 is a really impressive feat of engineering. Here are some examples around it. One of which I'm really impressed with is EDB's Postgres operator. So if you search for Postgres operator, right? Google, GitHub, there are tons of them all over the place. But EDB does seem to be the one with the level 5 operator. So Postgres operators are all over the place. But level 5 is impressive feat of engineering. Like itself, we do have a level 3 operator. Ivan, Argo CD, level 1, level 2, generally tasks that can be replaced by Helm, or Helm's a really good competitor to level 1, level 2 operators. If you're interested, check out the Enterprise DB documentation, really good writing. OperatorHub.io is so where you can find all of these operators. So, as I said, operators are quite available. Check out Operator Hub, GitHub, and all of that. So, one thing to note is that when you do have like a product, right, like Tyke itself, it may not necessarily be created or managed by vendors, the product vendors. I know Dell rolls out their own storage interfaces, network interfaces as well. Splunk, I think, owns their own one, but then there are a lot that are open source, like Postgres. So not all operators for a certain software are definitely maintained or created by the product vendors themselves. That gives us a lot of flexibility in terms of who to choose, what to choose, and each operator has its own maturity level around that. The one thing in which I will advise is, before selecting an operator, read the documentation, give it a try, understand your requirements, understand the capability level that you require, and before deploying them into production. One of the things which I also did think about as a topic, right, was actually like 5 horror stories of Kubernetes, but I'll save that for next time. Okay, so big question, should you write your own operator, right? There are plenty out there, easy way, git clone, use it, or get it from Operator Hub. Should you write your own? So at Tyke, we've actually rolled out our own operator, purely because Tyke is a very developer-focused product. We are API management software, and so there's a lot of demand for that. The one thing which I think, as part of my interview with the product team, as to why they actually rolled out operator, was that they identified repeatable tasks that are happening very, very often, and that's suitable for operators, right? Because you don't want people doing a certain task over and over again. So 2 things. One is identifying a repeatable task that you can automate. And number 2 is where I think operators should at least start from level 3, is task goes beyond install and configure. If it's a install and configure operator, you might want to consider using Helm charts, because Helm charts is a really solid package manager. It does a lot of the work. I think as of today, I can't count the number of Helm charts, but it's crazy many. Helm is a lot more popular for level 1 and 2 operations. So Why would you want to do that? If operators that exist today are not at the maturity level that you want, you might want to forfeit, extend that, or they simply don't exist. Or I don't know how many of you here are coming from a product or vendor company like I do, but rolling out your operator or rolling out operator support for that is potentially a user experience improving action. So at Tyke, we do have a lot of requests for rolling out Kubernetes operators for Tyke itself. They don't want to use the dashboard, they don't want to use the UI around that. They want to manage the APIs declaratively. So with that huge demand over there, it was really a no-brainer down the road to roll out operator. For us, we actually we rolled out operator in, I think, 2 years ago, but the prototype existed roughly about 3 years ago. It was about 2 months of work. It was really, really easy to build. I'll talk about what we used to build it and the challenges later. Last one, of course, for fun, for resume building, it's definitely good to have said that you've actually written the operator yourself. It's not easy because you have to embed some of the domain knowledge, specific knowledge in terms of what to do, like the core, like the etcd example over there. So you need to have some level of domain knowledge, some level of requirements in order to build like a really complicated operator. It's no easy task. So I've actually put in the right hand on the right picture from XKCD itself. If you're deciding to write your own operator or roll your operator out itself, some days it may just be easier to just not do it. I know I'm talking about operators itself, but you know, if you're wasting too much time around that, you're just better off doing things manually at times. Think about that. I think we've all been there at one point of time or another. So resources. So there are two popular frameworks that are available. Very strongly recommended. Don't do it from scratch. KubeBuilder and the operator framework or operator SDK. From Tyke's perspective, we wrote our own out with the operator framework using the SDK itself. It was relatively pleasant task, I would say. Using the frameworks, it was easier. But I would say from a product perspective, it took a couple of months to refine, and we're still refining that as the product grows itself. So if you're interested, check it out. I would say that it's an experience. Let's put it that way. Okay, so we're going to bring that all together. Small meme over there. Operations folks versus me. This is an example of a customer's deployment. This was actually co-innovated together with a very early stage customer of ours who was trying to get us to push out the GitOps team. They were really early customers trying to say, look, an operator would be really useful for you guys. What should that look like? So we work with them. This is drawn in, of course, Excalibur. But this is on very high level what we do recommend for any of our customers today. When they go on board of Tyke and they're really not on GitOps itself, they can take inspiration from there and start from here. So the one thing which I would just advise you to put aside first is ignore the Tyke Cloud stuff. That's our SaaS service around that. But other than that, all of the other components, including our cloud components, can be managed by operator. So if you recall my example just now, S3 being managed by that, cloud resources remotely can be managed by operator itself. So they push the code into CI/CD, and depending on tests passing, they would actually promote between staging and production environment, and all of that would eventually go down into Tyke Cloud. So this is a reference architecture that we often use. Case by case, it would differ a little bit, but I would say if we were to zoom out into 20,000 feet view, that's about it. Great, and one time. So summary, CDRDs and operators take it beyond. It's really, I would say, our Kubernetes has really made it easy for people to extend. It's a very, it's a learning process, but they made it possible, which is where we have operators right now. The tasks can range from simple to complex, as you can see from there. if you are someone from an operations background, consider operators. There are plenty of them, different maturity levels. Try them, use them, understand I would say for operations people, do understand that. Don't treat operators like a magic black box, because the things that you cannot diagnose are generally the things that are the most dangerous for you, because you don't know the inner workings around that. So try, test it, run your own even if you want to. And for those of you who are coming from a vendor background, SaaS background, startups, you might want to consider pushing out an operator as a strategy to increase customer experience, customer retention, increase stickiness, value proposition around that. So that's one of, I would say the last point is one of the things which would be a far end thing that's not really operations perspective, but from a product perspective, it would be quite a valid consideration. With that, I think I am on time. Ritesh gives me the thumbs up. I'm MK from Tyke. So on top is my LinkedIn and below is the Tyke website. Feel free to scan and connect. I'll take any questions from at the back there.
Any questions?
How much time do we have?
4 or 5 minutes.
4 or 5 minutes.
Schedule?
Should be. Let's see. Okay. Okay, so I'm going to show it on Tyke, of course. That's where I'm the most familiar with. So Tyke is an API management platform. If you search for us, we are known for API gateways. We are generally within the top 3 of any searches that you find for API gateways or API lifecycle management over here. These are the APIs that I have over here. If you're not coming from an API development background or you're not familiar with that, that's fine. Treat these as me creating something new over here using operator. Let's do it that way. Let me move. I've set up operator. Luckily, I did. And I've set up operator on my local machine. Everything's local over here. We've seen that this is local host. So what I've done is I've created a very simple API definition. There is a CRD. Let's get VS Code up, drag it across. So what we've done is we've actually created a custom resource, which we call an API definition itself. You give it a name, you give it a security authentication mechanism. If you're familiar with OAuth, OIDC, these are the authentication mechanisms for API. Protocol, the target URL, as well as it's a path here. And that's basically custom resource. All we have to do is, okay, let me clear. So all I have to do is use same commands. As I said, it's the first class citizen. kubectl apply app HTTP YAML. I can check on it. Same as usual, first class citizen. Can see that it is successfully deployed over here. So what happens as a result of that is when I go back into my dashboard, really. Wow. Okay, I know why. Okay, regardless, I will show you the result for that, because the dashboard doesn't really matter. One thing about that is, bear with me. Let me just undo this. Sorry, Ritesh. Let me undo this. Let me delete that. And we'll hit this endpoint. So if I have to go with this one which I just was created and I hit it now, can see that this doesn't, oops. Seems to be. I'm not blessed today. Hasn't deleted that. Okay. I know I'm out of time, but if anyone's interested in looking at the byproduct, I'll be at the back.
Yeah, thanks. Thanks, MK. Yeah, demo gods are not happy on you today.
And silence yourself. Yeah. Sound okay. Good. Yeah.
Hey, evening everyone. My name is Weiyuan. So I'm going to be here today to share with you some experiences and lessons that I learned in terms of migrating one of my ex-company's applications towards using Google Kubernetes engine. So there'll be some technical components, but also some perhaps like interesting learning lessons that hopefully you'll be able to extract for your own migration process. Maybe if you're doing it for your company in the future. All right, so yep, I'm Weiyuan. I'm a GDE for Google Cloud. Just to be clear, what that means is that I'm not an employee of Google Cloud. I'm just really obsessed with using Google and their technologies. So sometimes I think time to time you'll see me speaking at some of their events. I do use their technology on the side for side projects to share with different people, what they do. Okay, so let's go into the main topic. All right, so today I'm going to walk you through a few case studies of these products that I've used to migrate to GKE. So some of you might be familiar with this different brands of product. Hopefully you are. So okay, Rakuten, I think maybe that's a big enough name, but Rakuten Viki in Singapore, I don't think it's a popular enough product lah. So yeah, Rakuten Viki itself is a VOD platform for Asian dramas. You can think of it like Netflix, but mainly their audience is, I think, in the US. Sumpi is another application. Sumpi is this product that's owned by Viki, and it's a Korean news publication platform. Okay, so today I'm not here to sell to you these platforms, but essentially, if you're a fan of Korean drama, K-pop, right, you might have heard of these names before. Okay, small disclaimer over there, I don't represent these companies today. Like, this is a past employment, but because of the opportunity I had in terms of using their application to migrate to Google Kubernetes engine, I want to share with you some of the learning lessons I had with them. All right, so let's start with the first chapter, what I will call the pain points or the death by 1,000 cuts, which is essentially the reason, all of you, when you have to do like some sort of migration for application to one stack to another, right? Usually there's some form of motivation, why you have to do it. And for us, in each of these two different case studies, there's actually a very strong reason why we had to do so. So starting off with Viki first. So that two different products, okay, for the two different products, going with Viki first, right, there was actually a very big reason why we had to make that move. But not exactly towards Kubernetes, just that there was a very big reason for us to do so, which is that we were on this different unnamed cloud provider. Why is it blinking like this? Okay. We were on this unnamed cloud provider that's not Google Cloud. But essentially what happened was that I think weeks on end, we had a lot of infrastructure issues, reliability problems, essentially, virtual machines going down, essentially causing a lot of problems on our side. PagerDuty was essentially ringing back to back, for days on end. And it's creating a lot of issues for us. That's why we were kind of already evaluating other cloud options. And that was what really accelerated ourselves towards migrating towards a different cloud provider altogether. Okay, yeah, so as I mentioned, yeah. So we really evaluated and trying to figure out like whether we can move to other cloud providers. But as we were thinking about moving to other cloud providers, we were also thinking about, shall we actually, change the way how we are running our applications? We're still deploying on like virtual machines in that different cloud provider, using our own scripts to be able to do that deployment, kind of prehistoric, self-created processes that not really using like open source solutions to make our life easier. And part of the reason why we decided actually to go into using Kubernetes was actually behind the other product that I talked to you about, which is Sumpi. So the interesting story here goes on that, before we even had this issue with Wiki, right? The same product, Sumpi, in the same company, right, actually even had an even larger issue. This time it's not about the cloud, but this time it's about this. Okay, just want to, I think some of the folks might be familiar with who these people are. For those who don't, for those who know, please don't spoil it for the rest of the folks because there's a story behind this. But essentially, for those who may not know who these two people are, I think in the Korean fandom, like maybe 5 years ago, they're essentially called the Song Song couple. And they were behind this hit drama called, I think, Descendants of a Sun. Okay, and what happened was that, after the drama and, there was a lot of people who shipped them, if you know what the word ship means. And essentially, they actually went on to become a real life couple after drama and they got married. So, okay, that's the interesting part of the story. The technical portion, right? Why was this a problem for us? Okay, so they got married and then essentially, we had a thundering herd hitting our website at the point of time where we published the news, because we were a Korean news publication platform. So we published the news, and then essentially our site just went down because we were running on a older system, like just running on VMs, and we were trying to vertically scale. We had very, very bad practices, for running our applications back then. Okay, so services went down, we couldn't do anything about it. That's where the product team, engineering team, DevOps all came together, and we came to a realization we have to do something about this. Like, we have to redesign the whole system from ground up, not just the infrastructure, but even the application itself. So that was also part of the big motivation why we went towards Kubernetes. And because we actually went towards Kubernetes first using Sumpi, and it was successful, that's why that motivated us to also use the same for Wiki later on. Okay, so that's the kind of a problem statement. Hopefully, when you are doing your migration for your product, in your company, right, you might be able to find those same reasons as well. Any reasons can be justified as long as you figure out whether, those are the good reasons for, whether it's benefiting engineering, product, so on and so forth. But moving towards Kubernetes, right, I think there's an even bigger justification that within your teams that you have to make for yourself when you are moving your products to using something like Kubernetes. Okay, so I found this very interesting advertisement. I'm not sure if you all have seen this on Facebook before. Okay, and the company name is over there. I don't represent the company, just to be very clear. I don't work for Commodore. But essentially, I think for anyone, right, who's doing this migration of your product, right, from infrastructure, from let's say virtual machine to Kubernetes, or even anything else, right, you might be thinking that it's an insurmountable problem. You know nothing about this new platform, this technology, and your team essentially, you have very little knowledge, right, on how to do that migration. So it looks like a very huge Herculean task for you to essentially be able to succeed, and you may take like a huge amount of time. And I'm here to tell you that it's not that case. It's beyond the technical aspect, difficulties of it. I think there's a big part of success, right, that can be attributed to how your company faces these problems and how you all tackle it together. Okay, and I'm here to sort of introduce to you the let's say as a leader of your own company, right, how can you actually prepare your company to move towards Kubernetes? So using the 3 Ps, I'll explain that. The first P itself, if you are familiar with the 3 Ps, is product, process, as well as people. So in order to prepare your company to move over Kubernetes, firstly, starting with a product first, make sure you understand what you're moving towards. In our case, right, we're thinking about, should we move towards Kubernetes or should we use, other types of applications? So the fun fact here is, just now I was talking about Sumpi, right, how we move this Korean news publication to a different cloud environment in Google Cloud and also using Kubernetes. But the not so widely known thing is that we actually didn't just move to Kubernetes. We moved to both Kubernetes and App Engine because we had multiple teams, right, who were running the different applications, microservices in this entire product. For the front-end teams, they actually weren't as aligned or as technically inclined in using Google Cloud. So they wanted a more simpler way of running the application. So they use App Engine. Then for the backend services, you have multiple services, microservices in your backend stack, right? We wanted to have something that's much more easy for us to manage our cluster of services. So we use Kubernetes instead. Okay, so you have to question yourself to understand, is the product really right for you to use? Is Kubernetes really right for that? Like I said, if you want to go serverless, that can be another choice as long as you can justify it. process as well. Is your company ready at the point of time to do that migration? Let's say for certain companies, I'm sure like for certain companies where you may not have developed, let's say your DevOps knowledge well enough in a company, maybe you haven't even reached the area of containerization yet. So moving over to Kubernetes itself, you also want to make sure you have your application images, right? Back in some registry somewhere in the cloud where you can deploy very, very easily. But if you haven't even reached there, right, it might mean that a migration to Kubernetes means you need to uplift your entire systems. So you might want to think about the time and the process that's needed to do that. But beyond that, I think the one big thing I really learned about doing this entire migration to Kubernetes, right, is making sure you have the right people, the right culture in doing this migration properly. This is, I think, the backbone of anything, right, or projects that you're running in a company, which is, do you have people that are invested in learning, this new technology, in creating and innovate with it? And if you're not able to do that, and if leadership is not strong enough, right, you probably won't even succeed. You'll take years to do that migration, or you'll never even finish. You may even have to revert altogether. And I'll talk about that a little bit, like how you can inspire your own teams to do that. Okay, so going to the people portion of it, just to mention that I think just now the previous speaker spoke about Helm charts, right? I think that's something that I also want to encourage you all to use as well. I think that's something that I also learned when we did our migration to Kubernetes. The first time around when we migrate for Soompi, right, we actually went with the imperative way, which is just use kubectl, apply your YAML configuration and do the deployment. But after some time, we realized that you need to have like some sort of templating library to help you do your deployments, make it reusable, to ensure that it's easy, for anyone in your company when you do the migration, right? Any other teams, right, who's not knowledgeable in Kubernetes should be able to quickly migrate. Okay, so using something like Helm charts to build that reusable deployment packages so that anybody can just migrate right away. Okay, and I think one really big thing I learned about this entire migration process as well, right, is making sure that you make people excited about the process, right, to do this migration. Training, we had multiple internal trainings in the teams itself to sort of encourage each other to do that. There's even things like competitions, like we had one afternoon where we all just came together, right, and everyone just look at, their previous virtual machine configurations and see how they can migrate the new Helm charts. Essentially just, of course, we are not thinking about migrating by the end of it, but we're trying to just, help each other learn and see how we can get each other to the new systems at once. So I think that's something that I learned a lot, which is in the brand of Wiki, right, Rakuten Wiki and other migrating for Soompi, right, that strong leadership and the strong commitment towards getting people to do the migration. In fact, not just looking at it as an extra toy task, under let's say everyone's work for their individual teams, giving them the free bandwidth to do that migration as well, right? Get them interested and involved, right? Even sometimes pushing people to do those certifications, right? You'll be able to get them to move things more quickly and successfully as well. And I think testament to that, one thing I didn't put in the slides, but one thing that happened, right, in our migration for Rakuten Wiki back then was that the whole process, I believe, took less than a year, which was quite good, like given that this is getting the whole company to migrate to using Kubernetes. Okay, I'll skip this part. So I think essentially by being able to motivate, I think beyond the technical aspects of it, being able to do this type of big migrations, right, it's about getting the people to be interested and invested and involved as well. And I think that rather than looking at like this, right, it should be, you should look at migrations and changes in your companies, right, more like this, like trying to get the people to be on the same page so that you'll be able to be entirely geared up, right, to do this migration successfully. Okay, enough about the pep talk portion. So I think that's the part that I feel is the most important in terms of preparing your teams, right, to migrate to using GKE or Kubernetes in general. But I think some of you might be here for maybe the more technical portions as well. So I do want to introduce a bit more about Google Cloud related technologies that you can use to complement, this migration towards using Google Cloud. Okay, so one of the very interesting challenges that you might be faced with is, of course, you are thinking about containerization and where you can put your Docker images in the cloud. And definitely some of you might be using, let's say, like paid services like Docker Hub, but maybe you might not know that you can actually use Google Cloud to store your Docker images as well. Okay, but the even more confusing problem is that some people might even know that there's actually more than one solution to save your images in Google Cloud. Like, are you serious? Like, usually most of this other cloud, okay, let me make sure there's no other, oh, there's some Google stuff here. So I love Google Cloud. But yeah, the other cloud providers actually don't make it so confusing, but somehow in Google Cloud, they have two solutions. Okay, but there's a simpler explanation to all of this, which is that if you were to choose between these two different tools, right, and you're not sure about the pros and cons, the general guidance is go for artifact registry. Okay, but if you want to know deeper, right, in fact, there's like comparisons out there. So container registry itself, there's some benefits to using container registry, which is that it's cheaper in terms of storage costs. Okay, but don't let that guide you towards that first. If you go towards artifact registry instead, right, you'll find that there's more benefits there, which is that, okay, of course, it's version 2, it's more updated, but there's also other benefits, like, giving you more granular IAM access. What this means is that rather than at a Google Cloud project level, right, let's say you grant a single user access to your container registry repositories. When you grant that, right, that means they have access to all of them. But for artifact registry, what you can do is you can actually grant at the level of each of these different repositories. So if you just want to, let's say, have multiple Kubernetes cluster and then allow, let's say, different products or different teams access to different groups of these repositories, you can do that using artifact registry. Okay, and then if you go back to cost as well, right, actually artifact registry might come out to be cheaper in the long run, because for container registry, it's considered as a global storage, but in artifact registry, because you can choose it regionally, you save on network cost. Okay, I'll share these slides later, but you can, I think I got some of this knowledge from this blog post, so you can go and look at this later as well. Okay, see some people taking photos. 3, 2, 1. Okay. I'll go on to the next slide. Okay, another big thing is, okay, so containerization is just one part of preparing you to move towards using Kubernetes engine on Google Cloud. How about, let's say, if you want to replace your CI/CD system, or let's say you're self-hosting your own CI/CD systems, one recommendation I'll give to you is why not use something like Cloud Build on their environment rather than hosting it yourself. There are multiple benefits of doing so. Easy YAML configuration like GitLab CI. Some of you might be using GitLab and GitLab CI where you're hosting the entire environment in Kubernetes, but you can also do the same with Cloud Build as well. Very easy to configure. It's quite performant. Like you can basically be able to draw like, one flow chart on how you're going to run your entire CI process and make it execute as quickly as possible rather than running it in series. There's also as the entire Google Cloud ecosystem, right? The very good thing, as I said just now for IAM, but now with Cloud Build, right? The thing is you actually have this benefit of not having to, get like some secret token out and embedding, with your other CI systems that you use, in other environments. If you're using Cloud Build, which is part of a tool, right, in Google Cloud, together with GKE, essentially what it means is that you have direct access. There's a service account in your Cloud Build environment where they can access your Kubernetes cluster directly, they can access your artifact registry directly, they can access even your serverless environments directly. So you don't have to, embed some sort of secret token to allow your CI/CD environment to be able to do something. Yes, it actually makes it a lot easier. If you want to secure access, you don't risk exposing or copy pasting accidentally those secrets anywhere. Okay. Other benefits, if you are a hacker as well, you'd like to, or hacker as in like builder, you want to build more functionalities for your CI/CD tools, definitely I would recommend that, you check out the pub/sub integrations towards Cloud Functions. I've used that. I've used that to innovate, within Rakuten Wiki itself to build, things like being able to automate, Slack notifications, GitHub status updates. And then what happens is that you can just use this reusable functionality and just ask your other teams, right, to place it within the CI/CD configuration in Cloud Build. So you make it such that they can just reuse it directly. They don't need to build it from scratch. Other benefits, definitely I would say cost is also like something that we gain, or rather like save by, instead of self-hosting ourselves, using Cloud Build in Google Cloud. Yeah, so this one is something I shared in one of my previous sharing. So essentially how you look at this is equivalent to 1 year of 525,600 minutes. And essentially what happened was that we were self-hosting our own build environment, right? CI/CD environment, where we were running this virtual machine instance 24 hours for, let's say 1 whole year. And when we compare it against an experiment where we did use Cloud Build, right, for 1 whole year, right, you can see that we're actually using a lot less, in comparison, which means that we are likely also paying a lot lesser. Okay, beyond, the artifact registry and container registry for containerization, as well as for CI/CD tools, how about, in terms of cluster management? What can you use Google Cloud to exploit their tools, right, to make your cluster management much more easier? Okay, so this one I think is a bit of a duh moment. Like, of course, you can use Cloud Console as the web page. What's so special about it? I'd like to sell it a little bit by saying that, of course, when you bring up the cluster for the first time, it's probably the only tool you have to access that cluster itself. You probably wouldn't even have set up the kubectl at the point of time. And it's good for you, for several reasons. Of course, like being able to view and edit the config. I'm not sure if anyone has actually edited the configuration in the Cloud Console before. You can actually do that, okay, but it's the imperative approach, you may not want to do that most of the time, only for emergency or urgent cases. But beyond that, I think the value that it brings to you, right? You being able to access the Cloud Console is, of course, being able to set up, use the cloud monitoring systems and alerting tools inside the Cloud Console collaboratively, rather than, in kubectl where you won't have access to do that. Yeah, so yeah, this is just a screenshot I got from the Cloud Console. Yes, you can edit, you can create a whole cluster and go and try editing yourself if you want to. But of course, they also expose different kubectl actions like, auto scaling, scale up, rolling update, things like that. But that said, I'm not telling you all to always stick with Cloud Console. Do explore the other tools as well. I'm sure all of you know what kubectl is, but actually just curious to understand, anyone here knows what K8S is? Oh, okay. So for those that use, kubectl, maybe just ask kubectl. Okay, we have some hands here. So for those who use kubectl daily, right? This is a quality of life update. Go and try K8S. I assure you, it will help you out a lot. Don't memorize the kubectl commands. If you like using Vim, right? Essentially, it's kubectl on steroids. Like using a Vim text-like editor. So please go and try that. This is not Google Cloud stuff. But I'm just saying that, like, go and try out K8S. And if you like, you can also install things like Kubernetes, dashboard. That's cloud agnostic. You can just use it across your different cloud environments. Okay, and one last thing to mention in terms of you migrating towards Google Cloud, just want to caution that there is this myth about the free tier, right? Which is if I go to cloud.google.com free, right? I just want to caution that, yes, they mentioned over there that the autopilot in the zonal cluster per month, it's free, but it doesn't really mean that the whole thing is free, okay? Because what it means is behind the scenes, right? I mean, you're supposed to run like a virtual machine or cluster, right? So you have to pay for the instance as well, okay? Okay, but I'm not here to discourage you. I'm just here to tell you, that there is some price that you have to look at in terms of, trying out the Google Kubernetes engine, this tool itself. Okay, but I've also tried out, this over the recent weeks, just to give you also like, let's say, how much does it cost if you were to run it yourself? This is me running my own side project. I'm bringing up this cluster maybe around 6 hours a day. So, and you can see over here, it's like maybe the peak of it is like maybe just $1 a day, running 3 virtual machines, E2 standard 4 VMs. So these are pretty moderately sized virtual machines. And if you want to run your own side projects, or you are looking at migrating your workloads in your own company towards using Kubernetes, you can be assured that it's not going to be very expensive as well. Okay, so I've brought you through a story in terms of our migration journey, as well as like some tips in using Google Cloud. I do want to end up the story because I know some of you know about that Song couple thing. So that's one of the funny things that some of us talk about in the company back then. Okay, so the thing is, yes, our servers died in 2017 when they got married. And some of you might know what happened 2 years after that. So yeah, for those that follow K-pop news, right? Yeah, they got divorced 2 years later. And yes, the same hurt hit us again. But hey, we didn't die this time. We were on Kubernetes, we didn't die this time. Pretty good news, right? But actually, the story goes beyond bigger than that. Okay, so yeah, alarms went down from regular daily, weekly occurrence to rarely occurring, which is really good. But beyond that, we actually managed to get this entire system to a really good performance. And it's not just because of Kubernetes. I mean, to be honest with you, it's not just of this magic of single cluster orchestration that get us there. Actually, we also did a lot of optimization of our applications. Instead of using a single monolithic application, a multi-page monolithic application, we moved it towards a single-page application with server-side rendering, aggressively cache it as much as possible, because for our publication application, it can be eventually consistent. We don't want to keep changing the contents of an article. We also use this thing called Varnish. Maybe some of you are familiar with it. It's a HTTP accelerator. If you are running web applications, it's actually really good. The grace mode as well as the request coordinating actually help us out a lot whenever we have thundering herds. But the really good news is, together, all of these improvements brought us down from like more than 1 second, even sometimes 10 seconds of load time, right, down to less than 10 milliseconds at times. I think at the best I've seen is like 7 or 8 milliseconds loading time, which is mainly just a network hop lah. That means you probably hit the cache instead. Okay, so beyond that, okay, I'm running out of time, so I'm just going to run through this really quickly. So definitely, I think me going through this migration process because of the inspiration from the company itself. Definitely, I was brought through this entire certification process for myself last year, going through the CKA certification and also pushing myself to get some Google Cloud certification. So if you are part of a journey, like, similar journey like that for your company, right, and you haven't gotten any of these certifications, I would actually, suggest that you try out for it, challenge yourself, see that whether you have gotten to that level of knowledge, especially CKA. CKA, I'm not sure if, for those who have taken it, right, this is really, really challenging. But the end of you taking this, right, it's a really rewarding experience as well. It's not an MCQ test like most of the certification exams out there. You're dealing with virtual machines as part of the test. But if you can get it right, it's really a seal of like excellence in terms of your skills in using Kubernetes. Okay, I'm gonna skip this, so because I think I've run out of time. And yeah, if you want to find me up for more conversations. I know I didn't dive in too deep in terms of the actual nitty-gritty details of the Kubernetes migration, but I wanted to share more in terms of how, like, the mentality we took when we did that migration and how we made it successful. So if you are curious to know more, like, reach out to me. I'd love to talk to you all. Thank you.
Thank you, Weiyuan. Thank you very much for such an insightful session. Anybody has any questions? Okay, all right. So that was a wonderful. Oh, there is one question. Okay.
No, we did not use that one. This was the integrated experience.
Any other questions? Okay.
Why you migrate to the Kubernetes from so normal what we are mentioning in our is high. So how do you prepare to automate this when we deploy the current application to the Kubernetes service. So previous time there mostly some application will use the share script to deploy in the virtual machine or the other Kubernetes server. At this time, when you move to the Kubernetes cluster, so we need deploy automatically, right? At this time, they wish to did you use to automatically deploy your application?
Yeah, to understand the question correctly, I think in the end, the DevOps team moved towards using hosted Spinnaker. So we did, okay, I know I mentioned about CloudBuild. We use part of that in terms of our CI process, and then that's linked towards Spinnaker that someone else built within our company to do that deployment towards using the GKE today. But actually, if I'd like to make a recommendation, I know this may not be the best recommendation, which is if you are a startup or a small team or small company, right? Actually, I might suggest running using QTabs instead. I'm not sure if people know about QTabs, but I think it's a lot easier to just bring up this performance system really quickly, allow you to, let's say, host your own packages, cloud packages, and be able to deploy that directly to your Kubernetes engine or other Kubernetes clusters for other cloud providers. Does that answer your question? Like, or is that what you think?
Yes. Normally we just use the Yugabyte and Kubernetes and apply, right? So if we have the many microservices, so we cannot manage. So at this time, then we need to apply automatically, right?
I would suggest try out QTabs. Okay, Spinnaker, I don't think it's the easiest to bring up, but QTabs, right? Once you look into it, I think it's quite easy. Like for myself, I was able to bring it up for another company from a different cloud provider. But I think it took like just 1 day or 2 days. And to master it is really simple as well. Logging in, you able to see all your applications and bring up the new applications. If you want to give you some references as well later on, yeah.
How about the path of Terraform or Azure?
So
maybe you can take the questions later. we are running out of time. He will be here, so he will reach out to you. We can just discuss everything. Sorry, but yeah, we have to continue. We have another speaker, and we are running out of time. And thank you, Weiyuan. Please do a round of applause for the one to
Sorry.
And now we have third and last speaker, Yogi Rampuria from Yugabyte.
Thank you. Just give me 1 second. So I have been warned to share my screen. So done that.
Yeah, you can see us.
And what the heck is that? I don't know. Monstrosity. Yep, that's the one that I wanted to show.
Hi, everyone. I'll try and move to the middle of the sessions that everybody can actually see. My name is Yogi. I work for Yugabyte, and a bit of introduction about myself, and I think I'm out of range. Oh. I went too further actually. So yeah, my name is Yogi. I stay in Singapore. I am a solutions engineer at Yugabyte, and those are all the companies that I have worked in past. VMware, Pedro, Standard Chartered, and background. Very short career. I see two colleagues, ex-colleagues from my time there. Sorry about the time that I gave you. All right. The topic that I chose today was stateful applications on Kubernetes. Why I chose this is prior to working for Yugabyte, I had about 4 years of experience on Kubernetes, about 30 plus implementations of Kubernetes-based projects across the region, ranging all the way from Pakistan to Philippines. But when I got to Yugabyte, that was like first day in, and I'm looking at a stateful set, and I look at a few things in it, and I'm like, I've done a CKA, CKAD, but never really encountered these things. What the hell are these things? So it's been a learning for me. So I thought it would be a good idea to share some of those learnings and how Yugabyte actually uses Kubernetes. And of course, the key objective is to garner community feedback. If you see something that you say you think that can be done better, please, this is your chance to actually point out and let me know. I'll put a community Slack link, so do join the community Slack to give any feedback. All right. So, quick overview before I go there. How many of you have actually written a stateful set in Kubernetes? How many of you have written a stateful set in Kubernetes that was not for CKA exam? Have you actually written a stateful set definition? I think you raised your hand. What was that for?
Mostly there is sometimes you need to pull the type of data. So
what was the software that you were trying to run?
So mostly that I just run the like PostgreSQL other database application for it.
Yeah, don't run Postgres on Kubernetes. Don't run database on Kubernetes unless it's Yugabyte. And that's the only marketing message that I'm going to give. All right. Yes, you are absolutely right. Running database, that's the perfect stateful application that you can run on Kubernetes. Right? Database that you can run on Kubernetes. Stateful typically, like you can say caching or messaging systems. These are the stateful parts of your system. Right? How do you run them? Right? Stateful set is the object that is provided. That's the resource that is provided by Kubernetes to us for leveraging, right? Why? What is so different about it? We are going to explore a little bit and how Yugabyte actually uses some of the mnemonics in its day-to-day work. So pod, everybody's aware, smallest unit of deployment, that's undevices, right? Then you have deployments, which is bread and butter. Everybody does deployment. Everybody and their grandmother, right? Whether you're using operator, Helm chart, GitOps, anything, everything at the end of the day has to be a pod, right? Then of course we have a deployment. Stateful set, we are going to explore a lot more about it. Daemon set, has anybody written daemon set? You have. Yeah, we need to have a chat. So daemon set, the only time I've found myself writing a daemon set is when I was actually trying to create my own kubecast clone, where I would run it on each and every node and
collect stats for pods that are being run or containers that are being run on those pods, plus running certain agents, especially. So those are the times that you use the daemon set. Because the good thing with daemon set is, even if you scale your cluster, the new node will have the pod that you have specified in the fields, which is a good thing. And job, who has written a job? You didn't raise your hand, or you've written and you're tired, like, I don't want to raise it. Job is like, it's like you want to do something one-off and run to completion. Typically, pod is like a long-running process, whereas a job, it runs to completion. So it could be a scheduled job, whether it's migration, log cleanup, or something like that you want to do. A job is a perfect unit. So what makes stateful sets interesting? So first thing that you realize is that of course the time is the stateful set, right? The second thing, this is a new thing that you get as a volume claim then. So unlike say deployment, where you have a fungible volume, that means a volume from pod number 1 that was spun up can probably go to a pod number 2 within your deployment. In stateful set, volumes are actually given importance. Every pod that is spun up by a stateful set has an identity. And the volume that is associated with that pod will always be reassociated or reattached to that pod. It's very important, especially if you think about stateful applications where you have pod number 1, pod number 2, pod number 3, and you're putting something on pod number 1, something on pod number 2, and something on pod number 3. And you keep sort of a track of that metadata that, oh, this one sits on pod number 1, right? And just imagine if the volumes were interchanged. That is what we call in computer science data corruption. Your records are not the reflection of reality. So that is why stateful set actually gives you the ability to reattach the volume to the right pod, even after it gets restarted. Even if you scale it up, scale it down, and things like that. It provides the ordering guarantee for the pods. So if you're doing rolling out upgrades, if you do 0, 1, 2, if you're trying to do scale out and scale in, it will actually shut down, say if you're scaling down, it will shut down the latest pod, right? Pod number 3, then 2, then 1, and then 0. So that is something that is guaranteed. Pods are identical, but they are not interchangeable. So they will come from the same container image, but each one is sort of treated in a unique manner. All right. Everything that I have discussed here is from the documentation on Kubernetes website. So why would you use it? So some of it I already mentioned. It gives you a stable and unique network identifier. It gives you a DNS address all the way down to the pod. And I will show you how that works. When it comes to the persistent storage, I already mentioned that it gives you a persistent storage that is not interchangeable. It goes with the pod itself. When you're scaling out and in, it does a graceful scale out and scale in. That's very important, especially in the stateful manner, stateful workload scenario. Some of the key limitations before you sort of just jump into it is if you want a network identifier for pods, then you need to have a headless service. How many of you know what is a headless service? Come on, show me. Don't worry, I didn't. I was a CKA. I didn't know what was a headless service. So headless service is a service that actually does not get a cluster ID. So it doesn't matter what type of service you run, whether it is a load balancer, load port type of service, or a cluster ID service, it always gets a cluster ID. But a headless service doesn't get a cluster ID. The reason for that is it is sort of an indirection for the underlying pods that it is referring to. I will show you an example of how that works. And that is something we use quite extensively in Yugabyte DB as well. Just in case if you're not familiar, Yugabyte DB is a distributed database. It's a Postgres compatible database. So you're able to run it in Kubernetes and you are able to get the same capabilities as Postgres without the limitations of Kubernetes, right? So the PVs that are created by stateful sets, you have to clean them up manually. So typically in case of deployments, if you complete the deployment, PVs get cleaned out. In this case, they don't. You have to actually clean them out manually. And that's by design. Then the pod terminations are not guaranteed because of the stateful nature. If you just like sort of scale down or delete the stateful set, there could be instances where the pods are not cleaned out. They might be holding on to some sort of storage handles, and that is something that is by design. Headless service, it's a very interesting one. So for example, you created a headless service named service, like in this case, right? I have this headless service called service under this particular namespace. So normally, when you reference anything from a deployment or something like that, you just stop at that service name there. You don't go beyond the service name. Just say service.namespace.svc.cluster.local, and that's it, right? But in case of a headless service, once you create a headless service and actually tell a stateful set that this is the headless service that you need to go and associate yourself with, every pod that is associated with that service will actually be referenceable back. How many of you have actually seen something like this for the first time? Everybody have seen this before? Okay, you guys are way smarter than me because I never saw this until I actually saw it. It's like oxymoron. So this actually gives us a lot of benefit. Being a distributed database, we need to actually store data across multiple pods and need to keep track of which part of my entire data set is sitting on which pod, and being able to go to that pod in a resilient manner, because I cannot use IPs. IPs change, but this will not change. Yeah, so that actually gives us a lot of benefits. Now, some of the tricks that we use from stateful set in Yugabyte DB is affinity. So, especially when you deploy Yugabyte in a multi-AZ kind of a method, what we want to do is we want to keep we want to ensure that no two data pods are on the same availability zone. Why? Because if that entire availability zone goes kaput, the database service will still continue, because I still have the other two zones available. Right? So we use the affinity and anti-affinity rules to ensure that the pods end up in the right zone and no two pods in the same zone end up on the same host. We use those two techniques to ensure that all my workloads are actually spread across the entire cluster, and they don't actually create a sort of hotspot in the cluster on a single node. Another thing that you can leverage, we haven't leveraged it, but this is something that you can leverage if you are going to actually build anything which is using stateful set, is the labels. You can use the download API to actually get access to these pod indexes. So, for example, you write a Spring Boot application. How many of you know what Spring Boot is? Please show me hands. I haven't seen hands all evening. So, in Spring Boot is a Java framework which is useful for building cloud-native applications. If you want to create some simple, actually Ruby on Rails, Node.js, anything that you use and which actually creates, let's say, the schema in the database. You boot up the application and it goes and creates the schema. And let's say you run 5 instances of it, right? And all of them try to create those schemas. That's going to be a problem. But what you can do is you can actually leverage the download API, get the index, and if the index is 0, then only you run the migration. So that is something that you can leverage. The other thing that we use quite extensively is the update strategy. So we use a rolling update strategy. Within the update strategy, there is a key called partition. Now, partition is a very interesting concept. When you actually update a stateful sets image, right? Say, for example, my image right now is referring to V1, and I changed the image name to V2. but I want to control the go down. That means I don't want that all the pods to go down at the same time. I want to actually gradually update it. You can play with the partition key. So partition is a numerical value. You set it to 1, 2, 3, 4, 5, whatever it is. And what it will do is Kubernetes will actually go and update pods that are higher than that number. So for example, I run 3 pods under my stateful set, and I say my partition is 2. So it will go and actually roll out the update for pod with the index 2 and above. So whenever we do cluster updates, so we have an automation system on top of it, but even in open source, if you are actually deploying Yugabyte open source version, right, through a Helm chart, you can leverage the partition to gradually roll out the updates so that your cluster in one go is not. You can say, okay, let me upgrade pod number 3 first, then pod number 2, then pod number 1, then pod number 2. So this is a very interesting thing that will take right into these stateful sets. I have seen a lot of blue-green deploy kind of scenarios where people have actually created higher order operators and things like those. But yeah, if you sort of start looking at something like this, it's just baked into the Kubernetes. It makes things so much easier. So that was all the things. How much time do I have? Sorry, I lost track of time. So I'll show you how we are leveraging. 10 minutes? Oh, good. Thank you. No. What? Really? Let me know if you are able to read this. So what I have done is I have basically used Helm to deploy a Yugabyte DB cluster. Now, the commands that I used basically was something like this, okay? I gave it a values file, right? And I just used this particular Helm chart. And the values file is right here. It's very simple. You don't have to specify all of it. I just did it. I said, I want to use the premium RWO storage class for this. And I just specified how much resources I want to assign to all my pods. That's the basic part of it. Now, what this went and did for me is it actually went and spun up the cluster. The cluster itself comprises of, sorry. Oops. Just now somebody mentioned about K9, right? K9S. So this is K9S. If you've not seen it before, this is K9S. It's pretty neat. Like you want to look at stateful sets. Voila. You want to look at pods. You want to look at pods from all the namespaces. Voila. Right. So I use the Helm chart to actually deploy this. And additionally, I have deployed a pod called NetShoot. It's just a network troubleshooting tool. So over here, what you can simply do is, oh man, sorry. Somehow, okay. Let me just drop to shell. That was like an entire Kubernetes command, right? So here, if I do ns lookup, YB master, that's okay. That's what smart people do. Hello, yeah. So can you hear me? So YB master 0, YB masters dot, I'm in default, and then svc dot cluster dot local. Now, this is exactly what I told you, right? You are able to take the pod identifier and the service name and like the rest of it, and able to reference an individual pod from there. So same way, like I deployed 3 master nodes, 3 master pods, sorry. I'm able to reference them that way. I have a second, we deploy, oh, that's a donkey. So we deploy 2 stateful sets, one for master and one for T server. So our T server is the data plane and the master is basically a control plane. Now,
when we want to scale the reads and writes, we scale the T server part. Now, if I look at the definition of this T server, I told you a few things, right? Being able to actually reference the headless service. So my headless service name here is actually, see, headless service name. So first thing that I told you about headless service, it doesn't have an IP, right? So I have two headless services here, YB masters, YBT servers, right? Now, this, if I look at the definition of this T server, the cluster IP is none, and that's it. Everything else is same as normally you would put in a service. You still have a selector, because not anything can come and just stick with it. It needs to have the right selectors also. So there is that control. Now, if I click on this, and these are the services, these are the actual pods that are associated with this particular service. Now, if I go back to the stateful sets, how do I actually tell my stateful set that, hey, you go and actually stick to YB masters? How do I do that? Is through here. So can you see the service name field here? That's the attribute that controls, out of all the headless services that might be interested in YB master label, this YB masters headless service is what I want to go and associate. So we use that. I mentioned about, oops. No, please. No. Okay, we're back. I mentioned about affinity, right? So this is the pod NT affinity that we are using. So here you can see that very specifically, we are saying that, hey, don't schedule this pod on a node where there is another pod with that particular label. So that ensures that no two pods of mine, no two masters or no two T servers actually end up sitting on the same worker node. Yeah. When we actually deploy this in a multi-AZ environment, we add an additional affinity for zones. So I have not deployed it, but I have the here, which is ta-da. Yeah, node affinity. So here we leverage the standard zone labels from Kubernetes to ensure that my pod that I'm deploying in this stateful set goes and gets deployed on the nodes in a particular availability zone. So we leverage the affinity rules to target certain nodes and segregate pods from each other. We also use volume templates, of course. Volume claim templates. So, sorry guys. Each pod is sort of made to sit in a isolated and segregated manner. So if we want all my pods to be spread across everything, I do that. But within my availability zone, I don't want, like if I were to run more than one pod in an availability zone, I want them to not sit on the same worker node. I want them to sit on separate worker nodes, right? Yeah, so we use the volume claim templates to actually generate the directories and mounts and all those things. I mentioned about the partition, right? So here my partition is 0, right? Because if I were to actually roll out an upgrade now, it will upgrade all the pods with the index of 0 and above. So especially when we have large clusters, like, 50 pods, right? So that's where we use this to easily upgrade everything slowly. Because stateful set, the moment you set the value on the image, it will go and it has two ways basically of upgrading. One is on delete. So you have to go manually trigger a restart, which will basically do a delete of pod and then create new pods with new image. The other one is ordered upgrade, rolling update. So in rolling update, it doesn't wait for a pod to come up and perform some sort of check or anything. It updates one, it's up, goes to the second one. There is no waiting at all. Okay. So these are some of the techniques that we use baked into Kubernetes for deploying Yugabyte on Kubernetes. I think I'll pause at this point. I'll take questions because Ritesh told me I have 5 minutes. Yes, sir. Yes.
Want to talk to the database.
Yes.
Either if you talk or with the service name or with the
Let's have some fun, okay? You have a couple of options. One is you can always define an extra service, which has, just a simple selector, cluster IP and everything. It's not headless. Headless service is something that we are using internally to communicate with each other. You can choose to use the same headless service. Perfectly okay. Here's the fun part. It actually acts like a CNAME. Let me show you. Okay. Boom, 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 boom. Okay. K8. So for example, if I do ns lookup, okay, yb-masters, that should do actually. Now, do you see the response that it gave me back? It actually gave me multiple responses back. So from an application perspective, what happens is, I think sometimes it even randomizes the order. So like, you have that. So from an application standpoint, you can actually create an extra service, which is not a headless service, and you'll have like a load balanced access to everything. Or you can just use the headless service address, and it acts like a CNAME for you. Yeah.
Then the data level just use the data.
Now we get into the Yugabyte side of it, which is in case of Yugabyte, unlike Postgres, you can read and write on any pod. In case of Postgres, MySQL, even Oracle, or any standard RDBMS, you can only write on the master. Yugabyte is masterless. It's peer-based. You can actually rewrite on any. Yugabyte will take care of writing to all the other pieces. You'll have to actually talk to me after this. It's 100% ACID compliant, so it supports transactions and everything. So it's like if you write on from one node and then there's another write coming from the other node, all that is taken care of. Yeah, it's ACID-based transactions. Good question. Thank you. Any other question? All right. Thank you very much. Thanks for your time. Sorry. Hey, Zoom quit, is it? Or you throw me out, is it?
I'm pretty sure with your own support. Okay, so yeah, just to share the upcoming events, and the reason we list all of the events is yeah, all of you don't want even you're not in Australia, you're not. The time actually wasn't bad. You can join us. Our next one from Australia, we're going to run at Red Hat on 4th October. And then Singapore, we're going to have next one, 17th October. And if you guys are interested to join the HashiCorp user group, actually was organized by Ritesh.
So that's 13th of October. And then we have the 19th of October, we have a K8SUG Canada. And followed by K8SUG Australia at Microsoft on 9th November. And the last one, we also November, we have the Singapore team with at Rockton. Last one, Cube Day. Have you guys heard of the Cube Day? I guess no. That's normal because Cube Day is coming to Singapore for the first time. That's December. Actually, it's not free, but we're trying to manage to get some, discount. If you guys can ask your company to not just register now, but if you pay by yourself, we're trying to get the discount code to share with our community. Okay. So next page. Did we share the link earlier? We already shared the link of volunteer. So anyone willing to join us as a volunteer, as a speaker, or a sponsor, or anyone willing to join us as a sponsor or speaker, feel free to join us. Please help us to spread the word. I believe we do have some giveaway today from our sponsor. Yeah, this is just to highlight the next Cube Day event. So we are glad to be part of the organizing team to help Linux Foundation to organize the first Cube Day here in Singapore. Okay, did we touch this one? Yeah, just to highlight a few co-organizers from our Singapore team. Yeah, we are looking for more organizers, volunteers. Yeah, please join us. And so far, we have 2 of the active volunteers. That's Siva and Babesh. Yes, and we need more volunteers. So come to join us. And I do have some swags, but I want to be able to share with everybody. So because it's pretty costly, I ordered some CNCF t-shirt and also socks or a fanny pack. I have to keep for now for our volunteers. But in the future, if I can get some more sponsorship from the CNCF, likely I can get the t-shirt for everybody. I'm willing, to get the more funding to purchase more swags for everybody. So please help us to fill out the feedback form. And once you fill out the feedback form, we're going to get all your names, and we will have the wheel of the names. Yes, and we will give away the swags. Yeah, only the first few, right? How many? I can't remember how many. Okay. Yeah, please help us. Provide us the feedback, and for us to optimize, to enhance our meetup. And yeah, in the meantime. Yeah, and once again, thanks to our sponsor, CNCF, Google, CloudCasa, JFrog, and without them, we will not be able to, host these meetups every month. So thank you very much for the sponsors. Yeah, this side. Okay.